What's up, everyone, and welcome to episode 5 of Drew Sorta Knows Science. I'm Drew, and thank you for listening. So today we're going to talk about a little bit of physics, a little bit of astronomy, and then talk about a new figure of physics, Johannes Kepler. So let's get into it. First thing we're going to talk about today isn't about something happening in physics right now, but instead we're going to talk about the Big Bang. So I think the idea that a lot of people have about the Big Bang is that it was just a massive explosion a long time ago that kind of just puked out everything we know of today into existence. But we're going to talk about a little bit more of what it was, and if you find any of it interesting, like I always say, please look some of it up for yourself. Take a deeper dive into it if you want. So the universe right now is growing larger and larger, but for it to become larger, it means in the past it had to be a lot smaller, almost infinitely small. And right now, when astronomers make observations, they can see that everything is moving farther away. Everything is expanding. And this was first noted in 1927, that everything that we know of in the universe is expanding from one point in space. But now we actually know, because of Edwin Hubble, that the universe is also accelerating. And this is caused by dark energy, which we've kind of talked about before in previous episodes. So nobody really knows exactly what that is yet, but there's a key word in there, yet. So one day, hopefully soon, we will. But we can also see the cosmic microwave background, also known as the CMB, which is pretty much the earliest remnant of the universe that we can see. And from our observations, we can tell that it's about 13.8 billion years old. Now, this was discovered in 1964. Now, the Big Bang wasn't like a bomb explosion. You see a movie, you see a bomb go off. That's not like what this is. What it was really just a very, 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 very rapid expansion of space and time. It was the beginning of space and time. And an explosion moves energy from one point to another, but this expansion carried energy along with space as it expanded. Now, it started as very dense and very hot, but the initial expansion cooled it enough to be able to form subatomic particles, and then later on atoms. And then as time went on, giant clouds of early elements, mainly hydrogen, formed by being pulled together by gravity, and this became the beginning of stars and galaxies. And over time, as the cycle of the universe went on, it started to create what we now know today. And nobody really knows what the future holds for the universe. There was ideas in the past that it was going to be like some rubber band effect, that the universe was going to expand but reach some maximum point, and then it was going to begin to shrink in size and kind of collapse in on itself. And they called this the Big Crunch. But most physicists do not believe that that is the case. But again, nobody really knows what's going to happen. But if you are interested in learning more about the Big Bang, I urge you to download an app. I believe it was created by CERN, but it's called Big Bang AR, Big Bang Augmented Reality. It's a free app, and the whole thing takes, I think, about 10 minutes, but it kind of leads you through this video process, I guess I could say, of the formation of the universe. It takes takes about 10 minutes, you can see it in the space around you because it uses your camera on your phone and stuff. But it takes a deeper dive, kind of how the timeline of when things began to happen and what happened, and through there you can read various things about what all happened and stuff too. So I urge you to download that. We're going to talk about Big Bang from the world of astronomy. Now, yesterday was May 2nd, which was National Astronomy Day. I think it was May 2nd. So I thought it'd be kind of cool to throw this in there. Planet 9. We're going to talk about this hypothetical planet that they think might be out there on the outer region of the solar system. All this information I got from Scientific American, and there's a lot of evidence out there for its existence. So let's talk about it. So beyond Neptune in the Kuiper Belt, there's millions of icy objects that orbit the sun, but the orbits of 6 of these objects are clues that another distant and massive planet might be out there. So the 8 known planets, that being Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, orbit the sun in roughly circular orbits, and all on the same plane, called the ecliptic. Now, orbits of 6 of objects are elliptical and about 20 degrees, or tilted about 20 degrees off of the ecliptic. 2 clues of a large gravitational field. Now, Neptune is big enough to steer objects into elliptical orbits, but these 6 objects are too far away from Neptune to be affected by it. And they all reached their closest approach to the sun in generally the same region, which is another clue that there could be another planet out there. Now, computer models that they used suggested it's a 1 in 15,000 chance that these 6 orbits are just like that. They're just like that by chance. So the odds are not likely that it would just be like that. But it's more likely that there is a planet out there, which they're going to continue to try and search for. But that would definitely change a lot in what we know of our solar system. So I think as time goes on and they find more information about that, I will definitely keep mentioning it. But alright, to finish up this episode, we're going to talk about the new figure of physics, Johannes Kepler. He lived from 1571 to 1630. So, like usual, just going to talk a little bit about some of the things he did, and if you find any of it interesting, take a deeper dive for yourself. So, he was the first to correctly explain planetary motion, making him the founder of celestial mechanics. And from this, he created his 3 laws of planetary motion. The first being that all planets move in elliptical orbits with the sun at one of 2 foci. The second being a line segment joining a planet. A planet and the sun sweeps out in equal areas during equal intervals of time. And the third being the square of the orbital period of a planet is proportional to the cube of its semi-major axis. And these 3 laws were also kind of the foundation of Newton deriving his laws. So he was also the first person to formulate glasses for both far and nearsightedness. He was the first to explain how a telescope works. His book
explain
that
how a
I was
telescope
unable
works.
to
His book,
read the
that I
name
was
of,
unable to
but
read the
his
name
book,
of,
one of his
but
books, formed the
his
basis
book,
of integral
one of his
calculus.
books,
He was the first
formed
to
the
explain
basis
that
of
tides were
integral
caused by the
calculus.
moon.
He was
He
the
was
first
the
to
first to
explain
suggest
that
that the
tides were caused
sun
by the moon.
rotates about its
He was the
axis,
first to suggest that the sun
and he also
rotates
coined
about its
the
axis.
term satellite.
And he also
Plus, he
coined
did so many
the
more
term
things in the world of
satellite.
optics and in the world
Plus, he
of
did so many more things in
astronomy.
the world of optics and in the world
But
of
that's all I'm going to talk about today.
astronomy.
Again, if you found any of this
But
interesting,
that's all
please
I'm gonna
take a
talk
deeper
about today.
dive.
Again, if you found
If
any of this
you enjoyed
interesting,
listening,
please take a deeper dive.
please share.
If you enjoyed
And
listening,
as always,
please share.
feel free to go back and listen to
And
episodes
as
1 through
always,
4. Everything I talk
feel free
about
to go back and listen
in those
to
is still very
episodes
relevant.
1 through 4. Everything
But
I talk about,
I think
in
that's
those
it for
is
this
still very
episode.
relevant.
Thank you for listening,
But
and we'll see you next week.
I think that's it
Peace.
for this episode. Thank you for listening, and we'll see you next week. Peace.